All right. Welcome in roses. I refactored my code from that queue the other day so that I won't get yelled at anymore. um, all right. Nice. So I see the tricks of the 0 and the infinity. That's looking good. Looking better. Sorry if it feels like I yell. Hey Lucia, how's it going? Anyways, today we're gonna be doing the LeetCode weekly contest 390. No, you should say it. It helps. Okay, I can be annoying. I can do that. So let's start. Let's get started. Why not? Problem 1. Let me share the link. Lol. Maximum length substring with 2 occurrences. So why is this view? I was expecting the contest view, but now the link is more like the site. Virtual contest? Yeah, but I don't want to do the virtual. I usually do this and I get the contest look and feel. So I did the contest, but I used my personal account. And this is my streaming account. And this is the one that I use for the streams. That's why they are not all here. And we're going to do them from scratch. All right, okay, let's do it this way. So given a string S, return the maximum length of a substring such that it contains at most 2 occurrences of each character. And we get examples here. Example 1, so output is 4 because probably, so we cannot take all these B's because there are 3 of them. But maybe if we take this, there are 2 B's, so that's fine, and 1 C and 1 A. So I guess this is the answer here. This is the only one, I guess. Well, yeah, this is what they tell us here. And then here, of course, if we have all A's, then the maximum is 2. Otherwise, we'll have 3 occurrences or more. And well, notice as a usual, the easy, the sizes are small. So we can do, remember, if you have a size of 100, you can do a quadratic or even a cubic algorithm. So what do? We just go over all the, so I is going to be the start of the substring, and then J is going to be the end inclusive of the current substring, and we want to keep the count, so let's have a counter to keep the count of each letter in the current substring. So now we want to count S of J, which is the new character. We count 1, and notice that this is the one that could not satisfy the condition. So if count of S of J is already greater than 2, then we just break. We don't want to keep going on growing this substring because it won't satisfy the condition. And now we just max, so the length is J minus I plus 1, which is the usual when the ends are inclusive. And we need to have the maximum to keep track of it. And that's, and it passes. the examples. Let me share the submission. And so notice that this solution is quadratic because we have two nested loops, and here we're only doing O of 1 operations. So we are adding, so the counter is a hash table internally, and we're just adding a character and checking only that character. We don't need to check the whole thing. So if you could do this even as you could do this even as a cubic algorithm. So if you don't keep track of the things here, you could ask if the you could create a counter right here and use a slice. And then we want to know what the most common element, and this is going, so only the top one, and this is the count. And we want this to be less than or equal to 2, or we can say, as we did before, if it's greater than 2, then we break. And then we do this. So this should work as well. What is wrong here? Counter index out of range. Oh. Oh, this is no, this is the least. So this is the first element of the list of the most common, and then I want the count. Yes, you're right. Most common returns a list. And this doesn't work. Oh, because now this is not J is non-inclusive, because that's how slices work. So let's see if even if a cubic solution, yeah, so it works. And it's, well, I guess there are not many solutions yet, but yeah, even this thing works. I prefer the other solution. It's faster, and I think it's even simpler. So yes, this one, I guess the other one has the advantage that you could work it out as a one-liner in Python if you're into that. But I think this is pretty good. And then now, as a bonus, let's do this in C++. So it's pretty much the same thing, right? So we want to go over all the starting points, and no, we want to start from I and to the length, and here we want to create a map of cars. And so here again we count it, and if the count of S of j is greater than 2, we break, and here we, so this is, as you see, it's the same thing. It's not nothing too fancy here. And we got it in C++. All right. So to the second question. So I heard many people had trouble with this one. So it's called apply operations to make some of array greater than or equal to k. You're given a positive integer k. Initially, you have an array nums with only one element, 1. You can perform any of the following operations on the array any number of times, possibly 0. Choose any element in the array and increase its value by 1. Duplicate any element in the array and add it to the end of the array. Return the minimum number of operations required to make the sum of elements of the final array greater than or equal to k. And here we have an example. So k is 11 and the output is 5, must be 5. So here we increase by 1 3 times. So we end up with this array, and then we duplicate 2 times. So 1, we add the 4, and then we add another 4. So the sum is now 12, which is greater than 11. So that makes sense. And here we are already the sum already is greater at the beginning, so you don't need any operations, and the size is 10 to the 5. Okay, so here one thing that you might notice, so you have 2 options of operations, right? So here you don't know which one should I do. Do I need to do some kind of DP and try both? What is the optimal? But there is an observation here. If you think about it, you realize that it's always better to increase all the increments that you're going to end up doing. It's better to do them all at the beginning, because all those increments are going to be included in the duplicated elements, right? So that's going to make the sum as big as possible. So once you discover that, then you can just brute force. You can just try all the numbers of increments, and then you can just do an operation. You can just know how many quickly how many duplications you need to satisfy the condition to get a sum that is greater than or equal to k. Okay, because it's just a division. So the duplication is going to add that element, the element that was incremented to. It's going to add it any number of times. So the number of times that you need to exceed k is going to be the division. Okay. So that's why. So I don't think this is a math problem. I think it's more of a algorithm where you have to figure out, to make the observation that you have a greedy choice. You always want to increase first and then duplicate, and then it's a brute force once you know that. So let's code it. So when we want to find out what the minimum is, so we're going to have, so I is the increment. So the increment could be from 0 to k minus 1, right? If we initially we have a 1, so if we increment k minus 1, but this should be like this. The max number should be k minus 1, which means that after those increments we will have k as the value. So our initial value is going to be a plus 1, right? Because we had 1, and these are the number of increments. And now we need to know how many duplications, how many times we want to duplicate. So from k, now we're already with the first element. We're already adding x, so we can subtract it. And then we want to divide by x, because that's the number that we're going to be adding. But the only thing is that we need to do this division and rounding up. So I'm going to do this so that you can learn how to do this. So we want to minimize this. But now this is rounding down, right? Because that's integer division. So let's say that we have a ceil division of this. And I'm going to explain how to implement that ceil div of x and y. You can do that by adding to x y minus 1. Okay, so this should work. Oh, I'm not counting the increments in the cost, in the number of operations. Right. Correct. So why does this work? Why the ceil div works? Well, you can break it down into two cases. If x is a multiple of y, so the remainder when divided by y is 0, then notice that adding y minus 1 is not going to change anything, right? Because it's going to make the remainder to be y minus 1, which will be rounded down by the integer division. All right? But what happens if the remainder is greater than 0? Well, and this, when you add it I minus 1, even if it's 1, even if the remainder is 1, then you're going to add 1y more. And that's why it's going to be rounded up when it's divided. So that's why this works, and you should know this. This is something that comes up a lot, and it's better to do it this way instead of doing a floating point division and then using a ceil function. You usually want to avoid floating points to avoid precision errors. Okay, and we can solve this in a one-liner in Python with the min function, and then we just want this here. Okay, but we have to replace x by I plus 1. And so this is a one-liner. I mean, you can always inline this function. All right, so let's do it in C++ real quick. So here you don't have, I think you don't have the option of doing it in a one-liner, but it's not a big deal. So these are the number of, this is our value, and we want this to be the minimum between I plus, and let's do this directly here. So we want to divide by x, and we want to subtract subtract x from k and add x minus 1. So that means that we could cancel that out, and then we return res. All right. Done. 100%. Cool. So let's go 3. The most frequent IDs. I'll share a link in chat, and let's go back to Python first. So here, you're tracking the frequency of IDs in a collection that changes over time. You have 2 integer arrays, nums and freq, of equal length, and each element in nums represents an ID, and the corresponding element in freq indicates how many times that ID should be added or removed from the collection at each step. Okay, so you have a bunch of things that have IDs, and you're adding and removing some amount of them, and you need to keep track of the most frequent, the count of the most frequent IDs. So this is kind of confusing because they are assuming there could be more than one ID that has the maximum frequency. So this should be plural, I think. The most frequent IDs, the count of the most frequent IDs. That kind of confused me during the contest. So, okay, and the size is 10 to the 5. So here it should come to your mind that if you have to get a maximum each time, the maximum frequency, that you can use a heap data structure for this. The only difficulty here is that you're changing. So you could have pairs as the elements of the heap with the frequency on the first element and the ID as the second. But notice that when you make changes, you're changing keys that are not necessarily the minimum or the maximum. So one way to do that is to have this comes up a lot. You're kind of doing deletes in the heap, but they are delayed. So you have you need to have a secondary data structure that keeps track of the current associated values with the IDs. And so then when you want to pop the maximum, if you get a value that is outdated, that doesn't match the information that you have in the secondary data structure, then you just keep it, because it means that was deleted. So in a contest, maybe you do this quickly and you just wing it. But here we can take the time to do a class, a priority queue class, so that we encapsulate all this logic that I'm talking about, that has these two data structures that keep track of the elements, of the current elements, and the minimum and the maximum and so on. So let's do that. Let's have, because then the final code, so we need, on the one hand, we need a heap and we need also a counter. Let's use a counter to keep track of the value associated with each key. And so we're gonna have an update which will have a key and a delta. Okay, either we're adding or we're removing elements. So that means that the count of k will be modified by the delta, and then since our value associated with k changed, we need to add it to the heap. So we're gonna do a heap push. We add another copy. It doesn't matter the other copies that it may have of this key. Now they are invalidated because the counter has the most up-to-date information. And so here we add to the heap the pair. So since by default heaps are mean heaps in Python, we have to add the count negated. Hey, smart coder, we have to add the count as a negative, and then with the negative sign, and then we have just the key here. Okay, so that is our update, and then we want to check the top element. So this doesn't have any arguments. We just want to know what the top is. But remember what I said, that we want to skip all the values. So notice that this is not gonna, we're gonna be calling update and then top, so the heap is never gonna be empty. So we don't even need to care about that. So let's see, we want the count of the top element of the heap, which is the 0 element, the maximum. But here we have the second value of the pair is the key. So we want to check if the count is the count, and we correct the sign. So we want to say if it's not the latest value, then that means that element was invalidated. So we just remove it. So heap pop, and now finally we return from the heap the count. And again, we have to adjust the sign. All right, so now we have our data structure ready. So now it becomes very easy. We just have to go over the queries, and we create our priority queue, and we just push the new frequency, the frequency delta for ID I, and then we add the top to the result. So that is all. Pretty tight. Queue push. Oh, I didn't. Oh, update. Sorry about that. And accepted. Cool. So yeah, notice. So what I said was that maybe in the rush of the contest, you don't have time to encapsulate all this logic in a class. But sometimes it can pay off because it's not much code, and it helps you implement this in a very clear way without any of the details of the data structures. Okay, so let's do this quickly in C++. Oh, so this is a long vector. Why? Oh, because the frequencies can be big numbers? Well, I guess you could add 10 to the 5 times 10 to the 5, so that's 10 to the 10, and that doesn't fit int, so that makes sense. Maybe we can try here, do it. Well, no, let's do it with a class as well. Why not? So the PQ, so we're gonna have a priority queue of pair of long int and vector of pair of long int, and we want this to be a max, so I think here you need less less than pair long int. Is this right? And then we want a map that goes from int to long with the counts. And so we don't need anything on construction, and we want to update, and we want to pass a key and some value, some frequency. Let's call it delta. And here we just do this, and we also want to push the pair of C of k and k to the priority queue, and then we want to know what the maximum, so what the top, what we have at the top. So again, we have to do while the queue top yes, we want C of the second element. It's different than queue top the count. So if it's different than the count, we pop, and here we return queue top the count. Okay, so this is it. I'm not sure this is going to, is this parsing correctly? So here I have one open, close, open, close, close, open, close. That looks okay. I don't think this is less than, is it? C++ priority queue. Hey, Pat, welcome. How? less. It's just less. Oh, that's the default. So maybe I don't have to do anything. So the default is a max heap. Okay, maybe this is enough. Okay, so now here we just want to go over the nums. So, well, let's create the PQ and so here we just update nums of I and fric of I, and we push back to the result q top. So this is going to be the result, and we return that. So let's see if this works. Does not provide a subscript. Oh, this is, yeah, this is second, and this is first, and this is also first. Okay, forgot about that. Cool. Let's see if it passes. And it does. And it beats 100%. I don't think there are many solutions yet, maybe? I don't know. All right. So that's it for Q3. Let's go to Q4. Let's go back to Python. And okay, so this is just, so you get like a dictionary or words container. And then you get query words, and you have to find the longest common suffix, okay, of the query word with any of the words in the container. So this is just a try problem. So the fact that there are suffixes doesn't matter. It's just you can just reverse the strings and then you have prefixes. So that's why you could use a try here. And you have this condition to. So once you find, if you take the query word and you go down the try until you either consume the whole word, or you don't find any, you can't go any further because there's no word that would have that as a prefix. Then finally, you have to consider all the words that have that prefix, that common, well, I'm talking about prefixes because I'm thinking of the strings reverse, but bear with me. So you wanna already have pre-calculated what is the best word that has a given prefix in the try, right? And you have to use this criteria here for breaking ties. You want the smallest in length, and then you want to break ties by having the first one, the ones that occurs earlier in the list. And so that's pretty much it. There's not much to this problem. So you can do the usual try So we can make a try node, which is just this is going to have the next as a dictionary for going from one letter to another try node. And then we're going to keep track of the best index to complete the best completion for the current prefix. Okay? And so we're going to have a function here to add to the try the string s and the with index I. All right. So here, so the usual code is we go over the characters in S, and if the character is not in the next dictionary, we have to create a new node here, and then we move the node to the next node. And here, now that we have a new node, we have to update the index, so the best completion for this prefix. Okay, so either what the best one, so either if there's none yet, then we have to set it, we should set it to the current one, or if the length of the current one is less than the length of the words, let's call this word container and word query. So here, if it's the word container of the best one so far, so in IDS we have the best one so far, but if this is less than, strictly less, right? If they are the same, we want to keep the one before, because we're going to be adding them in order, and we want to break ties with the first one that occurs when they are the same length. That's what we're told. And so here we set the index to the current index. But notice that we also want to do this for the empty string, right? So we have to do this. The initial node of the try represents the empty string, and we also want to have to know what the best completion is for that. So we do the same thing here. Yeah, it's duplicated, but I think it's fine. So now that we have that, we can just and let's also have a function with the longest common prefix. Okay, that it's gonna get also the try and the word. And so we want to go again. This is the same code. So if char is not in the, but the difference is that we don't want to add more nodes. If it's not there, we break. And here, if it is there, we want to update to the next node. And finally, we return the index of the completion. Well, I guess technically it would make more sense to return the node, and then we do we get the index. I mean, it's the same thing, but all right. So now we create a try. We go over all the words in the word container, and we add them to the try, but we want to add them reversed, because this is about suffixes. And then here we go over the queries in the query words query, and we find the longest common suffix of the try for the query, again reversed. Okay, and we get the index of that. We append it, and that's pretty much it. I guess we can do this dictionary. Yeah, this is what? Longest common prefix. We are passing T, which is a try. Oh, here. Yeah, this is what I should have there. Right. And that's it. It's pretty simple. I think this was one of the easiest Q4s in a while. So we can do this like this to make it even shorter in Python. Word query. To make it even shorter in Python, we can do this, and it also works as expected. So yeah, this is pretty simple, and let's do it in C++. Here I think we can do something interesting, because yes, because I want to implement. So notice that in C++, if you create nodes new, and then you don't delete them, you don't release the memory that you have allocated, then you'll have a memory leak, and we don't want that. So another way of implementing a try is to just use vectors. So you have a vector that has, for each row is a node, and then you have a column. You have a column for each letter in the dictionary. And so yeah, so here we would have, so we would create a vector of what? Of int. Yeah. And this is our next thing, which initially has only one node, the root, and then we have a vector of size 25, and initially they are all -1. These are the links to the other nodes, which are indices in this implementation. And we also need the same thing for the best index. But this is just a vector of ints. Yes, for each node we want to keep track of the best index so far. Okay, so now we want to have a function to add a string, and well, So we need to have the vector, the next thing, and the idx. Is this gonna work? So yeah, I guess we could have this right here, or it doesn't have to be a lambda. I think we can just have a function here that is going to have, oh no, we do need a lambda now that I think of it, because we want to have access to the word container, the words container, and so here we need the string, we need the try, we need the string, and we need the index of the string. And we want to check if so we start at, so the current index is initially 0, which is the root of the tree. So we want to check if index of cur is either -1. Yeah, let's define the const int. So if it's nil, or the length of, so as length is less than the length of IDS of cur, then we want to update IDX of cur with the current index. And now so we want to go over the characters, and if the next of cur is nil, then we want to push back a vector of size 26 with -1, and we want to push back, yes, but first we need to update this to the size, and here we want to push back a -1 for this, well, nil. And so, and now then we update cur to the next of cur, and here we do this again. Yeah, and that is our add function. And we also want a longest common prefix function that also receives a try, and it receives a string, and it will go over, so cur is 0, and then it will go over the characters, and yeah, here this is pretty much the same thing. Yeah. So here we break, and cur is equal to the next, and here we finally, yeah, here I think we have to return and so the idx of cur. All right, so now we create the actual try. We go over the words in the word container and we add them, but we have to reverse them. How do we reverse? We have to modify them, right? Well, this I think it will be a copy, so that's okay. So I think we have to do this, and then we add, so we add s. Oh, we need an index here. Okay, so we add them, and then we go over the query. How was that? Call the word query, and again we have to reverse this, and we're gonna have a vector of the results, and we're gonna push back, and we want to call this with next idx and s, and that's pretty much it, I think. Let's see how it works. Binary expression. Oh yeah, we're not using the actual characters, right? That's makes no sense. So here, okay. Yeah, that makes sense now. So yes, every time we use this, we have to index by the character. Yeah, cool. All right. So this is how you can, okay, accepted. Cool. So yeah, this is how you can implement a try with just vectors. This is, I've shown you how to do it. And this is actually, I think it's more efficient in terms of hash locality, cache locality. And also it doesn't have the memory leak issue that I mentioned, and it makes sense, right? It's not just too fancy, I think. So yeah, I guess that's the whole contest in Python and C++, and I try to explain. I think this was a easier than usual contest. I finished the whole thing in about half an hour. But yeah, I heard that, yeah, I guess for beginners, it could be, there wasn't a second problem that was too easy. Like Q2, you have to make like 2 observations that were not trivial, and on Q3 you needed to know how to augment priority queue, which is might be a little advanced for a beginner. So yes, I can see how solving only one problem would be discouraging, but keep on keeping on, and we're gonna do better next time. Okay, so that's all I have for now. See you in the next one. Bye.